The ground beneath your feet holds a secret history of violence. We are only now mapping the true scale of ancient cataclysms that reshaped our world. This video reveals 20 ancient landscapes transformed by disasters, showing you precisely how these events forged human history and the modern map. You will discover how a single volcanic eruption erased a civilization from memory and why a cosmic impact redirected the course of life itself. What hidden force in your own region might be waiting to be uncovered? A powerful new magnifying glass is now in the hands of Earth detectives, revealing clues once thought lost forever. This is the promise of technologies like LiDAR and satellite radar interferometry, tools that allow us to peel back dense jungle canopies and centuries of soil to see the ghostly impressions of ancient landscapes. Space archaeologist Dr. Sarah Parkak calls this a golden age of discovery, and for good reason. These methods are fundamentally rewriting the stories we tell about our past. LiDAR works by flying over a region and firing millions of laser pulses toward the ground. By measuring how long each pulse takes to return, it constructs an astonishingly precise three-dimensional map of the surface, effectively digitally stripping away every tree and bush. Meanwhile, ground-penetrating radar can peer deep into the earth, imaging buried walls, roads, and even the subtle contours of forgotten fortifications without ever disturbing the soil. This is not merely a treasure hunt for lost cities. It is a profound shift toward understanding the immense forces that struck them. We can now trace the cracked foundations from a forgotten earthquake, map the lava flows that entombed a bustling port, and see the flood sediments that abruptly ended a dynasty. How would our history books change if we could chart every ancient cataclysm? The data is beginning to speak, guiding us directly to our first transformed landscape. Our journey begins not with a whisper, but with a city frozen in a single, violent moment. The buried city of Akrotiri on the island of Thera offers a window into a vibrant Minoan world, a sophisticated town preserved under layers of volcanic ash with a startling intimacy. Walking through its excavated streets feels like stepping into a paused film. You see multi-story buildings standing tall, their walls adorned with breathtakingly colorful frescoes of antelopes and fishermen, and even ceramic pots left behind as if the residents had just stepped out for a moment. This was not a slow burial. It was a sudden, catastrophic end from a volcanic eruption so immense it makes the famous event at Pompeii seem almost modest by comparison. This was the colossal Bronze Age eruption of Thera, an event that occurred around the year 1600 before the Common Era. The force was unimaginable. Geologist Floyd McCoy describes it as a caldera-forming eruption, one of the largest in all of human history. The volcanic center became so empty of magma that the entire middle of the island collapsed in on itself, sinking into the sea and creating the vast bay we see today. Modern geological surveys have mapped the incredible reach of this disaster. They trace the paths of scorching pyroclastic flows that raced across the landscape and model the towering tsunamis that would have ravaged coastlines across the Aegean Sea. The cultural impact was just as devastating. The Minoan civilization was a maritime power, a thalassocracy that ruled the waves with its fleet. The eruption from Thera effectively ended that dominance, crippling their naval power and trade networks across the eastern Mediterranean. The event was so profound, so earth-shattering, that many researchers suggest it lived on in collective memory, perhaps even seeding the enduring myth of a lost and advanced civilization, Atlantis. By meticulously mapping the ash layers and the shape of the submerged caldera, scientists can now piece together the eruption's precise sequence. This understanding shows us how a single geological event can erase a powerful civilization from common knowledge, only to be patiently rediscovered thousands of years later. The fiery power of the volcano gives way to another, slower but equally relentless force of transformation. That same volcanic power that can erase a civilization gives way to a force of a different kind, one not of fire, but of unimaginable quantities of water. The rolling farmlands of eastern Washington seem the picture of peace today, a quiet expanse of wheat fields. Yet the very soil tells a different story, one written in the language of catastrophe. This is the channeled Scablands, a landscape that was not built up over eons, but was violently stripped bare in a matter of days. The evidence points to a deluge of biblical proportions, where walls of water moved at highway speeds, carving deep canyons directly into solid basalt rock and leaving behind ripple marks the size of houses. The source of this cataclysm was glacial Lake Missoula, a vast inland sea held back by a towering ice dam during the last ice age. When that dam failed, and it failed not once but repeatedly, it unleashed a volume of water greater than all the world's current rivers combined. The resulting flood did not merely flow over the land, it scoured it, peeling away hundreds of feet of topsoil and exposing the dark bedrock across an area the size of the state of Rhode Island. For decades, the geologist J. Harlan Bretz championed this radical theory of a catastrophic flood, facing fierce opposition from a scientific community that believed all geological change was slow and gradual. They could not accept that such a monumental event could happen so quickly. Bretz was ridiculed for his ideas, but he persevered, meticulously documenting the field evidence. Today, modern technology has vindicated him completely. Digital elevation models and satellite imagery now map the undeniable pathways of these megafloods with stunning clarity. We can see the colossal dry waterfalls like the staggering Dry Falls, which was once 10 times the width of Niagara, and trace the routes of these torrents as they ripped through the landscape. This is not just a story of a flood. It is a story of how a single stubborn scientist, armed with observation, forced us to rewrite our understanding of Earth's capacity for sudden, violent change. From a landscape shaped by a flood of water, we now turn to one forged by a devastating flood of rock and debris. High in the stark beauty of the Pamir Mountains lies a body of water of such deep turquoise it seems almost unreal. Sarez Lake is a breathtaking sight, a long, serene ribbon of blue cradled by towering peaks. Yet this tranquility is a mask, a beautiful illusion hiding one of the most powerful and recent geological cataclysms on the planet. Its very existence is the direct result of a single night of terror in 1911. A massive earthquake shook the mountains loose, triggering the Usoi landslide, an event so colossal it remains one of the largest in recorded history. An entire mountainside collapsed, burying the village of Usoi and instantly damming the Murgab River with a wall of rock and debris over half a kilometer high. Imagine a dam twice the height of the tallest skyscraper you have ever seen, built not by human hands but by the raw, chaotic power of the earth itself. This natural dam, named the Usoi Dam, now holds back a colossal volume of water, creating Sarez Lake. The question that haunts scientists and the communities living downstream is a simple, terrifying one. How stable is it? Seismic surveys and satellite monitoring have become our crucial eyes in this remote region. A sophisticated technology called interferometric synthetic aperture radar, or INSAR for short, is deployed to detect the most minute shifts in the dam's structure. It works by repeatedly scanning the area from space with radar waves, measuring changes in the ground's surface down to the millimeter. This provides an incredibly sensitive early warning system, a way to listen for the slightest groan or shift in this gigantic earthen wall. Engineers and geologists meticulously map the internal pressures and the lake's rising waters, understanding that a catastrophic failure would unleash a flood of unimaginable scale down the narrow valleys, affecting millions. This landscape is a living, breathing lesson. It reminds us that the forces that reshape our world are not confined to ancient history. They are ongoing processes, and our survival may depend on our ability to watch, to map, and to understand the quiet warnings they give. As we monitor the precarious earth beneath this mountain lake, our gaze must also lift to consider threats from a far more distant source, written across a different kind of landscape. A scar of unimaginable scale lies hidden beneath the tranquil blue waters of the Gulf of Mexico. This is the Chicxulub crater, a colossal impact basin over 180 kilometers wide, the permanent mark of a day that reshaped the entire history of life on our planet. The calm you see today is a profound deception. 66 million years ago, a city-sized asteroid moving at cosmic speeds slammed into this very spot. The energy released was beyond human comprehension, billions of times greater than the most powerful nuclear device ever detonated. Geophysicists like Sean Gulick have led daring scientific expeditions using seismic technology to map the crater's structure deep beneath the seafloor. Their data paints a vivid picture of a peak ring, a ring of mountains inside the crater, and a precise sequence of rocks that chronicle the moments and days after the impact. This is not just geology, it is a forensic report from the scene of a global catastrophe. The mapping extends beyond seismic waves. Detailed surveys of gravity and magnetic anomalies have traced the crater's full, sprawling outline, confirming the sheer magnitude of the event. The immediate effects were apocalyptic. The impact instantly vaporized rock, hurling incandescent debris back into the atmosphere. It triggered mega tsunamis that swept across entire ocean basins and ignited global wildfires that raged across continents. But the true killer was what followed. The immense quantities of dust and sulfur aerosols thrown high into the sky blotted out the sun, plunging the planet into a long, dark impact winter. Photosynthesis ground to a halt, collapsing food webs and leading to the mass extinction that ended the age of dinosaurs. The meticulous mapping of this crater's morphology is not merely an academic exercise. It allows scientists to run sophisticated models to understand precisely why this single impact was so uniquely lethal. They can simulate the angle of impact, the composition of the target rock, and the specific gases released into the atmosphere. This event was a brutal reset button for evolution. It cleared the ecological stage, creating an opportunity for small, surviving mammals to emerge from the shadows and eventually diversify into the world we know today, including our own species. This cosmic cataclysm, the most famous in Earth's history, sets the stage for an even older and more massive collision. Far older and grander than the scar of Chicxulub lies a landscape that reveals the true scale of Earth's early violence. In South Africa, the Vredefort Dome appears today as a serene, semicircular ring of rolling hills, a beautiful feature that belies an origin of almost incomprehensible power. This is not a gentle upwelling of rock. It is the deeply eroded ghost of the oldest and largest asteroid impact crater we have ever found on our planet. Over 2 billion years ago, a projectile larger than the one that wiped out the dinosaurs slammed into this very spot. The original crater was staggering, estimated at 250 to 300 kilometers across. To put that in perspective, if it happened today, it would easily swallow an entire metropolitan area and its surrounding counties. For a long time, its true nature was a mystery, seen merely as an interesting set of folded rocks. The key to unlocking its secret lay in the subtle, telltale signs only a cosmic impact can create. Geologists discovered shatter cones, distinctive conical rock formations that fracture in a specific pattern only under the immense pressure of a shockwave moving at hypersonic speeds. They also found impact breccia, a chaotic jumble of rock fragments literally welded together by the force of the collision. These were the forensic clues that confirmed this was not a volcano, but the site of an ancient planetary-scale trauma. Modern geophysical surveys have mapped the dome's complex anatomy, showing how the Earth's crust, in the moments after the impact, behaved like a liquid. The center rebounded upward, creating a vast central dome before collapsing back into a multi-ringed structure. Billions of years of erosion have since stripped away the surface layers, acting like a natural scalpel to expose the crater's deepest roots. This gives us a unique cross-section into the planet's primordial crust, a view otherwise impossible to obtain. Studying Vredefort is more than an archaeological dig into Earth's past. It provides critical data for understanding the frequency of these mega-impacts during our planet's turbulent youth. These were events so colossal they could have vaporized early oceans and repeatedly sterilized the fledgling planet, fundamentally influencing when and how life could finally take a firm hold. As we contemplate these external forces from space, our attention is drawn back to the immense power churning within the planet itself, to a different kind of cataclysm that simmers just beneath the surface. The geysers of Yellowstone are beautiful, but they are also the gentle sighs of a slumbering giant. Beneath the park's iconic landscapes lies one of the planet's largest active volcanic systems, a gargantuan magma chamber whose past eruptions have literally reshaped a continent. This is the Yellowstone Caldera, a vast depression in the Earth over 70 kilometers across. Its very existence is the scar of a cataclysm, the result of the most recent in a cycle of 3 super eruptions, the last occurring 640,000 years ago. That event was so powerful it caused the land above the emptying magma chamber to collapse inward, creating the caldera itself and ejecting enough volcanic ash to blanket the entire continent, from the western coast to the distant Mississippi River. Today, the magma chamber is far from dormant. It is a restless, dynamic system, and we are now mapping its every subtle movement. A sophisticated network of technology keeps a constant vigil. GPS stations detect the ground swelling by millimeters as magma and superheated fluids push upward, then deflating slightly as they retreat. Seismometers listen for the faint rumbles of earthquakes deep below, while satellites equipped with InSAR radar create detailed maps of the caldera floor's slow, breathing rhythm of uplift and subsidence. All this data feeds into powerful computer models, allowing geologists to construct a 3-dimensional map of the volcano's intricate plumbing. They can trace the pathways of magma and assess the potential hazards, not to predict an imminent doom, but to understand the long-term cycles of such a system. By meticulously mapping the ancient ash fall deposits from previous eruptions, scientists can also model the potential reach of a future event. The result is a sobering forecast of how volcanic ash could disrupt air travel, alter global climate for years, and impact agriculture across the nation. Yellowstone, therefore, is more than a national park. It is a living laboratory that teaches us how to listen to the vital signs of a supervolcano. It reminds us that the ground we walk on is part of a dynamic, living planet, and that our future security depends on our ability to interpret the quiet language of the Earth itself. This immense volcanic system finds a dramatic counterpart in a landscape where the Earth's power was expressed not by fire, but by the sea swallowing the land whole. The wind-swept waves of the North Sea hide a secret continent, 8,000 years ago, this was not a sea at all, but a vast, inhabited lowland called Doggerland, a sprawling plain of forests, marshes, and rivers that connected Britain to mainland Europe. This was no barren bridge, but a rich ecosystem teeming with life, home to Mesolithic hunter-gatherers who tracked deer through its woods and fished in its waterways. Their entire world was on borrowed time, caught between two colossal forces. The first was the slow, relentless creep of post-glacial sea level rise as melting ice sheets steadily filled the ocean basins. The second was a single, catastrophic blow. Off the coast of Norway, a massive section of the continental shelf known as the Storegga Slide gave way, collapsing into the deep. This underwater landslide, one of the largest ever identified, triggered a mega tsunami that raced across the emerging North Sea. For the people of Doggerland, the slow creep of the ocean suddenly became a terrifying, rapid inundation, a wall of water swallowing their hunting grounds and homes in what might have been a single, fateful event. The story of this lost land has been pieced together not by shovels but by sound. Sophisticated sonar mapping from research vessels has painted a ghostly picture of the drowned landscape, revealing the sunken courses of ancient rivers like the Rhine and Thames and outlining the shores of vast, forgotten lakes. Oil and gas companies conducting routine seismic surveys of the seabed have inadvertently provided archaeologists with a treasure trove of data. These subsurface images show subtle anomalies that hint at human activity, potential settlement sites, and ancient hunting grounds now buried under dozens of meters of water and sediment. By analyzing core samples pulled from the seabed, scientists can read the environmental history like a book, identifying layers of peat from old marshes and even microscopic fossils that reveal the changing climate. The result is a series of stunningly detailed paleogeographic maps, a cartographic resurrection of a world lost to the waves. These maps show us that Doggerland was not a mere land bridge, but a core territory, a thriving ecosystem, and a major pathway for human migration for millennia. Its disappearance was a profound event, severing the physical connection between Britain and the continent and forever altering the cultural and genetic landscape of Europe. The story of Doggerland is a hauntingly relevant lesson. It demonstrates with chilling clarity how a landscape cherished and relied upon by humans can vanish, a casualty of both gradual climate shifts and sudden geological disasters. The slow, patient mapping of this sunken world stands in stark contrast to our next landscape, where the Earth did not sink, but was thrust violently upward. The slow crush of continents is a force that builds the very stage of our world. Nowhere is this more dramatically visible than on the colossal roof of the world, the Tibetan Plateau. This is not a landscape formed by a single, sudden event, but by a slow-motion cataclysm that has been unfolding for 50 million years and continues today. The engine of this transformation is the relentless collision of the Indian tectonic plate with the massive Eurasian plate. Imagine two gigantic sheets of the Earth's crust, one plowing into the other with unstoppable force. The result is the Himalayas, a mountain range that is still being pushed skyward. We are not merely observing a static monument to the past, we are witnessing an ongoing creation. Modern satellite geodesy gives us a real-time view of this monumental struggle. A network of highly sensitive GPS stations scattered across the plateau measures the land's movement with millimeter precision. The data reveals a staggering reality. India continues to drive northward into Asia at a rate of about 5 centimeters every year. This constant pressure does not just build mountains, it stores immense energy in the rock, energy that is released in the devastating earthquakes that regularly shake the region. Geological mapping tells the deeper story of this collision. It reveals the colossal thrust faults where vast sections of the Earth's crust have been stacked one on top of another, like a rug being pushed across a floor and crumpling into folds. This process has not only thrust up the world's highest peaks, but has also created the vast, high-altitude Tibetan Plateau itself, a feature so immense it actively influences the global climate system, dictating the monsoon rains that billions of people depend on. By meticulously mapping the rates of uplift and the patterns of erosion, scientists can now model the intricate feedback loops between the solid Earth, the atmosphere, and flowing water. This landscape is the ultimate testament to the patient, planet-shaping power of plate tectonics, a force that works on timescales almost beyond our comprehension. Yet for all its slow and steady power, the Earth is also capable of transformations that are shockingly swift and complete, a sudden collapse that can erase a world in an instant. The same continental shelf that held the lost world of Doggerland was also the source of its final, devastating blow. Off the coast of Norway, a seemingly stable underwater slope gave way in a single, catastrophic event. This was the Storegga Slide, a collapse of sediment so immense it would cover an area the size of Iceland. An entire section of the continental shelf, destabilized, slid into the deep abyss of the Norwegian Sea. The energy released by this submarine landslide was staggering, displacing a colossal volume of water and generating a mega tsunami that radiated outwards like a shockwave. The wave did not merely ripple, it raced across the sea, its power undiminished as it slammed into coastlines from Norway to Scotland, and most fatefully into the already drowning lowlands of Doggerland. The water that had been slowly creeping inland for generations now arrived as a terrifying, unstoppable wall. Modern marine geology allows us to see this ancient cataclysm in stunning detail. Research vessels equipped with multi-beam sonar have mapped the immense scar left on the seafloor. The data reveals a chaotic, hummocky landscape of debris stretching for thousands of square kilometers, a permanent testament to the scale of the collapse. To understand why it happened, scientists use seismic reflection profiling. This technology acts like an ultrasound for the Earth, sending sound waves deep into the seabed and mapping the layers of sediment they bounce back from. These profiles reveal the geological weaknesses, the slippery layers of clay or the pockets of methane gas that may have suddenly destabilized, turning solid ground into a fluid avalanche. The story is also written on land far from the slide itself. In coastal peat bogs across Scotland, geologists find distinct, coarse sand layers sandwiched between ancient plant matter. These are tsunami deposits carried far inland by the wave and left as a permanent record of its reach and fury. The Storegga Slide is a sobering lesson. It demonstrates that the greatest geohazards can lie dormant for millennia on seemingly stable, passive continental margins. Today, this understanding is critical for safeguarding the vast networks of underwater cables, pipelines, and energy infrastructure that now crisscross these same seabeds. It forces us to ask what other quiet slopes are holding their breath and what might cause them to finally let go. This dramatic rerouting of the sea finds a powerful parallel in a river system that was abruptly and permanently redirected on land. The silence of the Utah Salt Flats is a profound kind of quiet, a stark white expanse that seems to stretch into eternity, but this emptiness is an illusion. Beneath the thin crust of salt lies the memory of an inland sea, a colossal body of water known as Lake Bonneville. This was no mere lake, it was a prehistoric ocean larger than Lake Michigan, a vast freshwater sea that once filled this entire basin to the brim. Its existence was a gift of the last ice age, a time when the climate was cooler and wetter. Then, around 16,000 years ago, this tranquil world came to a sudden and violent end. The lake's natural dam, a constriction of loose sediment and rock at a point we now call Red Rock Pass in southern Idaho, could no longer hold. It failed catastrophically. The result was the Bonneville Flood, a deluge of almost unimaginable force. For weeks, a torrent of water equivalent to the combined flow of every river on Earth poured out of the basin. This was not a gentle overflow, it was a full-scale collapse. The water rampaged northward, scouring its way across the Snake River plain with unstoppable power. It is this very flood that carved the dramatic depths of the Snake River Canyon, a gorge that stands today as a permanent scar from that single event. Geologists have become detectives of this ancient disaster, walking the dry pathways the water once took. They map the evidence left behind, from massive gravel bars the size of small hills, deposited where the current finally slowed, to immense potholes and eroded basins ground directly into the solid basalt bedrock. They can even trace the skeletons of abandoned waterfalls, dry cataracts that once roared with the fury of the escaping lake. The most haunting clues, however, are written on the mountainsides that surround the salt flats. Etched into the slopes are crisp, horizontal lines like the bathtub rings of a giant. These are the strand lines, the ancient shorelines of Lake Bonneville. By meticulously mapping their elevation, scientists can reconstruct the lake's precise depth and calculate its staggering volume before the breach. The highest shoreline, called the Bonneville Shoreline, marks the lake's maximum fill, the moment just before the dam gave way. To understand the deeper history, researchers turn to the lake's last remaining fragment. The Great Salt Lake is the shrunken, hypersaline remnant of its mighty predecessor. By extracting long cores of sediment from its bed, they can read the climatic story of the region like the pages of a book. The layers of mud and salt reveal how the lake filled and emptied over tens of thousands of years, a pulse driven by the great Ice Age cycles. The Bonneville Flood was a regional catastrophe that permanently rewrote the map, demonstrating with brutal clarity how the failure of a single natural structure can alter the hydrology and geography of an entire area for millennia. This story of a landscape violently reshaped by a bursting lake finds a dramatic parallel in a continent where the Earth itself was torn in two. A continent is tearing itself in two. The East African Rift is a wound in the Earth's crust so vast it can be seen from space, a sprawling network of valleys and escarpments where Africa is slowly, inexorably being ripped apart. This is not a cataclysm of the past, but one unfolding in real time, a live broadcast of a continental divorce that will take millions of years to finalize. The driving force is a colossal upwelling of heat from deep within the mantle, a thermal plume that pushes the crust upward, stretches it thin, and finally causes it to crack under the immense pressure. The land sinks along parallel fault lines, creating the deep trough of the Rift Valley, while volcanoes like Mount Kilimanjaro and the bubbling lava lake of Erta Ale in Ethiopia mark the points where the Earth's molten heart bleeds through to the surface. To measure this slow-motion rupture, scientists deploy an array of sophisticated tools. Networks of GPS stations planted across the rift measure the ground's imperceptible creep, tracking how the Somali plate is pulling away from the Nubian plate at a rate of a few millimeters per year. Meanwhile, satellites equipped with radar peer down from orbit, using a technique called interferometry to detect the subtlest bulging and subsidence of the landscape, mapping the continent's stretching skin with breathtaking precision. This geological drama is far more than a spectacle. It is the very stage upon which our own story was written. The changing landscapes of the rift, captured in places like Tanzania's Olduvai Gorge, created a mosaic of shifting environments. Lush forests gave way to open savannas, a transformation that forced our early ancestors to adapt, to walk upright, and to develop new strategies for survival. The rifting process itself created deep lakes that provided vital water sources and preserved a rich fossil record of our evolutionary journey. This living laboratory demonstrates that the most profound cataclysms are not always sudden. They can be a slow, relentless pull that forges new worlds and even new forms of life over epochs. The immense forces that fracture continents find a powerful, contrasting echo in a single, tragic city frozen in a moment of time. Stone trees stand in silent testimony to a world erased by fire. The petrified forests of Yellowstone are not merely fossils, they are a chemical metamorphosis, a landscape where life was captured and turned to gemstone. This transformation began around 50 million years ago, when a series of volcanic eruptions far more extensive than the park's current activity buried entire ecosystems. Vast sequoia-like trees were flattened not by lumberjacks, but by searing avalanches of volcanic ash and debris. The logs were sealed in an airtight tomb, deprived of the oxygen they would need to decay or compress into coal. This was only the first step. The true magic, the alchemy that turned wood to stone, began when mineral-rich groundwater started percolating through this volcanic blanket. The water was saturated with dissolved silica, a chemical leached from the volcanic ash itself. Over centuries, this silica seeped into the cellular structure of the buried wood, molecule by molecule, replacing the organic plant material with a perfect quartz copy. The result is not a mere impression, but a literal stone replica, preserving the tree's annual rings, its bark texture, and even the intricate cellular pathways that once carried sap. The brilliant reds, yellows, and blacks that streak the wood come from trace elements like iron and manganese that infiltrated during this slow process. Meticulous geological mapping of these fossil beds reveals the layered history of the disaster. Scientists can trace the stratigraphy, the sequence of individual ash flows that smothered the land, and identify the precise geochemical conditions that allowed for such perfect preservation. By studying the petrified logs, paleontologists can reconstruct the ancient Eocene rainforest, identifying the types of trees that thrived there and piecing together the climate of a much warmer, wetter Wyoming. These stone forests are more than a beautiful oddity, they are a time capsule. They offer a frozen moment from an ecosystem that was thriving one day and entombed the next, a monument to a cataclysm that preserved even as it destroyed. From a vibrant forest frozen in gemstone, our journey takes us to a different kind of preservation, where an entire city was frozen in a cloud of dust. The legendary grandeur of Alexandria lies broken on the seabed. Founded by Alexander the Great as a beacon of knowledge and power, the city's most celebrated districts now rest in silent ruins beneath the Mediterranean. This was not a slow sinking, but a catastrophic collapse driven by the Earth's own violence. A series of powerful earthquakes, likely coupled with a local tsunami, struck the unstable coastline. The ground itself turned from solid to liquid in a process called soil liquefaction, where water-saturated sediment loses its strength during intense shaking. The land simply gave way, swallowing the royal quarters of the Ptolemies, the very palace where Cleopatra once walked, and consigning it to the depths. Modern underwater archaeology has resurrected this lost world. Teams of marine researchers glide over the site, their sonar systems painting a ghostly map of the submerged cityscape. They have located the fallen columns of grand temples, the scattered statues of gods and rulers, and the massive stone blocks believed to be the remains of the fabled pharaoh's lighthouse, one of the 7 wonders of the ancient world. Magnetometer surveys detect subtle magnetic anomalies, revealing the outlines of harbors, workshops, and foundations hidden under centuries of sand and silt. This meticulous mapping does more than just catalog ruins. It provides a tangible link to the pulse of the classical world. By correlating these underwater finds with geological surveys of offshore fault lines, scientists can now explain the tectonic instability that has plagued this region for millennia. The same forces that built the Nile Delta also make it vulnerable, repeatedly shaking and submerging humanity's most magnificent constructions. The story of Alexandria's sunken port is a profound lesson in impermanence, showing how natural disasters can erase even the most enduring symbols of human achievement from the land, leaving only echoes for us to find. This natural drowning of a great city finds a haunting parallel in a landscape intentionally flooded by human hands. The golden, crumbling cliffs of China's lowest plateau tell a story written not by a sudden impact, but by the slow, steady hand of human need. This vast expanse of deeply scarred earth, a labyrinth of gullies and stark hills, was once a lush, fertile highland, a cradle of early Chinese civilization. Its transformation is a cataclysm of a different kind, one that unfolded over millennia as generations cleared its forests for fuel and farmland. The very soil here, a fine, wind-blown dust called loess, was its greatest blessing and its ultimate curse. Incredibly fertile when anchored by roots, this soil becomes a powdery, vulnerable blanket the moment that protective cover is stripped away. Once the trees were gone, the intense summer rains had their way, carving intricate, destructive patterns into the soft ground with every downpour. We can now map the staggering scale of this erosion from space. Satellite imagery chronicles a landscape in retreat, with historical land use maps revealing the relentless creep of barren ground. The most visible consequence flows directly to the sea. The Yellow River, its name a direct result of this endless soil loss, carries an unimaginable load of this sediment, over 1 billion tons of topsoil every single year, coloring its waters and steadily raising its riverbed. This elevated riverbed, in turn, has made catastrophic flooding a recurring nightmare for communities living downstream for centuries. In response, a monumental effort of ecological engineering is underway. The Grain for Green project uses sophisticated GIS mapping to pinpoint the most critically eroded slopes, offering farmers incentives to plant trees instead of crops. The goal is to coax the land back to health, to rebuild the natural sponge of roots and leaves that can absorb rainfall and slow the flow of water. This landscape stands as a powerful, sobering lesson. It proves that the most profound changes to our world are not always born of fire or ice, but can stem from the accumulated consequences of our own survival. A slow-motion disaster that reshapes continents just as surely as any asteroid. This human-shaped catastrophe finds a stark contrast in a landscape scarred by a sudden, violent flood of a different kind, one that emerged from the Earth itself. The placid surface of the Black Sea conceals a coastline from a lost world. According to a compelling scientific hypothesis, these waters were once a much smaller, isolated freshwater lake, lying hundreds of feet below the level of the global ocean. Surrounding it was a vast, fertile plain, a potential refuge for early farming communities after the last ice age. Then, around 7,600 years ago, a cataclysm occurred. As rising sea levels from the melting glaciers finally topped the natural earthen dam that was the Bosporus Strait, the Mediterranean Sea began to pour through. What began as a trickle soon became an unstoppable torrent, a thunderous roar of saltwater crashing into the basin below. The proposed deluge was not a gentle filling, but a violent, rapid inundation that could have raised the shoreline by as much as 6 inches per day, swallowing the ancestral plains and forcing a massive, sudden migration of people. Could such a traumatic event have echoed through generations, becoming the foundational flood myth found in cultures across the region, including the story of Noah's Ark? Marine geologists have turned to technology to find answers. Using advanced sonar systems, they have mapped the submerged landscape of the Black Sea floor with breathtaking clarity. Their data reveals the ghostly contours of an ancient shoreline, a shelf that would have been the original coast of the freshwater lake. Even more striking are the sinuous, branching channels of drowned rivers, perfectly preserved underwater, tracing the paths of waterways that once flowed across the now vanished plain. To read the timeline of this event, scientists lower long coring devices into the seabed, extracting tubes of sediment that hold a layered history. The crucial evidence lies in the transition between two distinct types of mud. At a certain depth, the layers of freshwater mud, filled with the shells of lake-dwelling mollusks, abruptly give way to marine mud containing saltwater species. For some cores, this shift is startlingly swift, suggesting a catastrophic change. For others, the data points to a more gradual transition, fueling an ongoing and vigorous scientific debate about the speed and scale of the flood. Yet regardless of its precise nature, the Black Sea hypothesis stands as a powerful example of how the meticulous mapping of a submerged landscape can directly engage with the deepest threads of human cultural memory. It shows science grappling with the stories our ancestors told, not to dismiss them as mere legend, but to investigate the real-world cataclysms that may have inspired them. The search in these dark depths is a quest to bridge the gap between geological evidence and mythological truth. The dramatic cliffs of the Columbia River Gorge stand as a monument to hydrologic fury. This scenic wonder, with its cascading waterfalls and sheer rock faces, was not carved patiently by the river alone. It was massively enlarged and sculpted by the same unimaginably powerful Ice Age floods that ripped across eastern Washington. When the glacial dam holding back Lake Missoula failed, the resulting wall of water was funneled into a single, narrow chute, the Columbia Gorge. The torrent did not merely flow through this canyon, it attacked it. The floodwaters, charged with icebergs and rubble, scoured the gorge walls, plucking out entire pillars of solid basalt and grinding the bedrock smooth. The very waterfalls we admire today, like the iconic Multnomah Falls, are often the result of this violent scouring, where the floods carved away softer rock and left the more resistant layers behind as dramatic precipices. The true scale of this event remains hidden under a blanket of modern forest, but technology strips that veil away. Detailed LiDAR mapping of the gorge reveals a hidden textbook of catastrophic flow. The data shows giant current ripples, waves in the earth itself that stand dozens of feet high, frozen in time. It unveils streamlined islands, shaped like teardrops by the relentless current, and immense gravel bars of colossal boulders deposited where the water finally slowed its frantic pace. Geologists use these high-resolution digital maps like a forensic tool, measuring the size and spacing of these features to calculate the flood's incredible discharge rates. The numbers are staggering, suggesting flows that far exceeded the combined volume of every river on Earth today. This mapping also shows with brilliant clarity how the floods expertly exploited pre-existing weaknesses in the bedrock, like ancient fractures and faults, using them to rip the landscape apart and dramatically deepen and widen the gorge in a geological instant. This landscape is a masterclass in planetary power, demonstrating how a series of short-term, high-energy events can accomplish geological work that would otherwise take millions of years of slow erosion. The sheer force of water that carved this immense gorge finds a stark contrast in a landscape born from a much quieter, but equally lethal kind of eruption. A deep blue lake nestled in a volcanic crater can hold a silent, invisible kind of danger. In 1986, Lake Nyos in Cameroon was the site of a tragedy that seemed to defy the very laws of nature. One evening, the lake released a massive, dense cloud of carbon dioxide, a gas that had been accumulating for centuries from volcanic seeps at its bottom. This was not an eruption of fire or rock, but a limnic eruption, a rare event where the lake literally burped a colossal volume of suffocating gas. The invisible cloud, heavier than air, flowed silently down the surrounding valleys, displacing the breathable atmosphere. The result was a profound and heartbreaking loss of life, affecting over 1,700 individuals and countless animals in nearby villages, all without a single visible warning sign. The cataclysm was swift, silent, and utterly lethal. In the aftermath, the international scientific community mobilized to understand how a peaceful lake could transform into such a deadly force. The key lay in mapping the lake's hidden structure. Using bathymetric surveys, researchers created detailed three-dimensional maps of the lake floor, revealing its extreme depth and the specific topography that allowed for a dangerous stratification of its waters. They discovered that the lake acts like a giant pressurized bottle. Cold, CO2-saturated water sits at the bottom, trapped by a layer of warmer water above. If this delicate balance is disturbed, perhaps by a landslide or even a strong wind, the pent-up carbon dioxide can rush to the surface in a devastating explosion of gas. To prevent another tragedy, a continuous monitoring system was installed, keeping a constant watch on the lake's carbon dioxide levels. But scientists and engineers went a step further. They installed a remarkable innovation, a degassing pipe that acts like a giant soda straw. This pipe extends all the way to the bottom of the lake, allowing the pressurized carbon dioxide to be slowly and safely siphoned off in a controlled, continuous fountain. The success of this system has led to the installation of additional pipes, turning Lake Nyos from a ticking time bomb into a closely managed environment. Furthermore, detailed mapping of the crater's morphology allows researchers to model the precise flow paths a future gas cloud would take, information that is critical for emergency evacuation plans for the surrounding communities. Lake Nyos stands as a sobering testament to a rare but devastating geological process, a landscape that can hold its breath for centuries and then exhale with fatal consequences. It demonstrates with chilling clarity how scientific mapping and human ingenuity can work to disarm a silent killer. This quiet, deadly release of gas presents a stark contrast to the roaring, fiery cataclysm that defines our next landscape. The stillness of Pompeii is a profound silence. This was not a city that faded away. It was a vibrant Roman town captured in a single, brutal day in 79 AD. When Mount Vesuvius erupted, it did not just destroy, it preserved a moment of ancient life with heartbreaking intimacy. The event was a Plinian eruption, named for the historian Pliny the Younger who witnessed it from afar. This specific type of volcanic cataclysm began with a towering column of ash and pumice that rose miles into the sky, raining down on Pompeii for hours, collapsing roofs under the weight. Then the volcano's fury changed. For Herculaneum, the smaller seaside town, the end came not from falling ash, but from a ground-hugging wave of superheated gas and volcanic rock, a pyroclastic flow that instantly carbonized organic material and sealed the town in a hardened, rocky tomb. While the famous plaster casts of the victims offer a human connection to the tragedy, the real scientific revolution is happening beneath the surface, in the areas still untouched by shovels. Modern archaeologists are using ground-penetrating radar to send pulses of energy into the earth, mapping the echoes to reveal the outlines of entire city blocks, shops, and villas still buried. A complementary technique called electrical resistivity tomography measures how the soil conducts electricity. And because features like hollow rooms or buried walls conduct electricity differently, It can even detect the ghostly impressions of wooden objects like beds and cabinets that vanished long ago. Above ground, the mapping is just as detailed. Drones equipped with high-resolution cameras fly precise grids over the ruins, stitching thousands of images together into a perfect orthomosaic map, a digital twin of the entire site. Meanwhile, 3D laser scanners fire millions of points to create a point cloud model of every surviving wall and street, capturing the ruins with millimeter accuracy. This data allows researchers to perform virtual archaeology, testing how the volcanic materials accumulated against different buildings and digitally reconstructing structures to their original height. The meticulous mapping of the volcanic stratigraphy, the distinct layers of ash and pumice, acts as a timeline of the eruption. Volcanologists can read these layers like a book, reconstructing the eruption's phases, the direction of the winds, and the varying intensity of the fallout. This is not merely about the past, it is vital data for modeling future eruptions of Vesuvius, which still looms over the modern metropolis of Naples. Pompeii and Herculaneum stand as the ultimate paradox, where a cataclysm of immense destructive power also created the most perfect time capsule of the Roman world, a poignant reminder of both the fragility of daily life and the enduring power of discovery. From a city preserved by ash, we turn to a landscape created by it. From the silent testimony of petrified wood, we arrive at a structure so vast it can only be fully comprehended from the heavens. The Richat Structure in Mauritania, often called the Eye of the Sahara, is a colossal bull's eye staring up from the desert floor. For decades, many speculated this perfect circle was the scar of a cosmic impact. The truth, uncovered through meticulous geological mapping, is a cataclysm of a different kind, one measured not in seconds but in millions of years. This is not a crater but a deeply eroded geologic dome, a symmetrical anticline where immense tectonic forces once pushed the entire landscape upward into a giant, rounded hill. The cataclysm here was the slow, inexorable uplift of the Earth's crust, followed by the patient, relentless work of erosion. Wind and water spent eons stripping away the softer rock layers, acting like a natural sandblaster to gradually expose the concentric rings of harder, more resistant quartzite that we see today. These rings are not the result of an explosion, but are the exposed edges of the different rock layers that make up the dome's core, a cross-section of deep time laid bare. Satellite imagery has been the key to understanding this formation. From orbit, the sheer scale and perfect symmetry of the structure become breathtakingly clear, providing the perspective needed to map its 50-kilometer diameter and confirm its terrestrial origins. The Richat Structure stands as a monumental lesson in geological patience. It demonstrates that not all of Earth's most dramatic landscapes are forged in sudden, violent events. Some are the product of forces equally powerful but operating on a timescale that dwarfs human history, a slow-motion transformation that reveals the beautiful, layered anatomy of our planet. This ancient, eroded dome, shaped by the elements, brings us to a final landscape transformed by a fundamental component of the air itself. The stone forests of Guangxi rise from the mist like the ruins of a forgotten city, their jagged peaks a testament to a war waged not by fire or flood, but by the gentle, relentless chemistry of rain. This is a cataclysm in slow motion, a landscape transformed molecule by molecule over millions of years. The agent of change is karstification, a process where slightly acidic rainwater, absorbing carbon dioxide from the atmosphere, slowly dissolves the region's vast limestone bedrock. It is a chemical conversation between the sky and the stone, a quiet but unstoppable force that etches away solid rock, leaving behind a surreal world of towering pinnacles, gaping sinkholes and labyrinthine caves. We can now map the staggering extent of this dissolution from orbit. Satellite imagery and geographic information systems, or GIS, allow scientists to create detailed inventories of these karst features, counting thousands of individual towers and mapping the complex network of sinkholes that pockmark the landscape. The density and distribution of these formations are not random. They are a sensitive record of past climate. Periods of heavy, tropical rainfall accelerate the dissolution, carving deeper and more dramatic forms, while drier epochs slow the process to a crawl. This makes the karst landscape a sprawling, stone archive of the Earth's climatic history. Beneath the towers lies an even more spectacular hidden world. The mapping of vast cave systems like the Reed Flute Cave reveals breathtaking caverns adorned with speleothems, the collective name for stalactites, stalagmites, and flowstones. Each of these formations is a chronicle written in mineral deposits. By analyzing their layers, much like reading tree rings, scientists can reconstruct a timeline of water flow and mineral-rich seepage stretching back hundreds of thousands of years. A delicate straw-like stalactite might represent centuries of steady, drip-by-drip growth, while a massive column could tell a story of a much wetter ancient climate. This landscape, forged by the slow dance of water and rock, stands in beautiful contrast to the violent, instantaneous cataclysms we have witnessed. It demonstrates that the most profound transformations are not always loud and explosive. Sometimes the most powerful force is a persistent, patient chemistry, a quiet cataclysm that sculpts solid rock into breathtaking forms over spans of time that challenge human imagination. Having journeyed across 20 ancient landscapes, from cities frozen in ash to continents torn in two, a profound pattern emerges. These 20 landscapes form a grand mosaic of planetary transformation. Each one, from the instant fury of an asteroid strike to the patient pull of a continental rift, reveals a single, unifying truth. Our world is a dynamic system where catastrophe and creation are not opposites, but are deeply and fundamentally intertwined. The sudden violence that erased the dinosaurs also cleared the stage for mammals to rise. The slow drowning of Doggerland severed a land bridge and reshaped the cultural map of Europe. The epic floods that scoured Washington state deposited rich soils that would later support vast agriculture. Destruction and opportunity are two sides of the same geological coin. The key that unlocks these profound stories is the advent of modern mapping technologies. Tools like LiDAR and satellite radar are more than just fancy cameras, they are time machines. They allow us to see not just what happened and where, but to finally understand the how and the why. We can trace the precise sequence of a volcanic eruption from its ash layers, model the flow path of a megaflood from its ripple marks, and measure the slow, relentless creep of tectonic plates in real time. These maps reveal that cataclysms are not random acts of a chaotic planet. They are fundamental, recurring processes that drive the very engine of Earth's evolution. They reset ecosystems, force life to adapt or perish, and have repeatedly redirected the course of human history, determining where civilizations could flourish and why others were left as mysteries. This historical detective work is far more than an academic pursuit. It provides the critical data we need to model future risks. By understanding the frequency and magnitude of past earthquakes, we can better prepare our cities. By mapping the plumbing of a supervolcano like Yellowstone, we can forecast the potential reach of its ash. By studying ancient climate shifts preserved in ice cores and sediment layers, we can refine our models for a warming world. This knowledge is not just about curiosity, it is directly relevant to our collective survival and long-term prosperity. The ultimate lesson written across these 20 maps is one of profound humility and awe. We do not live on a static, stable stage. We inhabit a planet of immense, restless power, a world whose entire history is inscribed into the very ground beneath our feet. It is a language of stone and sediment, of uplift and erosion, waiting for us to learn how to read it. And as our tools for mapping improve, we are only just beginning to understand the stories it has to tell. Our journey across these 20 ancient landscapes reveals a world constantly remade by forces of unimaginable power, from the churning depths of the earth to the silent void of space. We have witnessed how modern science, armed with laser scans and satellite eyes, is finally mapping these profound cataclysms. This is a process of turning ancient myth into hard data and deep mystery into tangible understanding. The most vital lesson written in stone and sediment is this: Earth's long history is not one of solely gradual, gentle change. It is a story punctuated by dramatic, violent events that have shaped everything from our coastlines and mountain ranges to the very course of evolution itself. The same planetary forces that buried the vibrant city of Akrotiri under volcanic ash and carved the channeled Scablands with walls of water are not extinct. They are still at work today, stretching continents along the East African rift and pressurizing magma chambers beneath our feet. By studying these past events with such incredible precision, we do more than satisfy our curiosity about yesterday. We gather the essential data needed to prepare for the possibilities of tomorrow, helping to build more resilient communities on a dynamic planet. Let this exploration stand as a powerful reminder. The ground we walk on holds fascinating stories of transformation hidden in plain sight, narratives of fire, ice, and impact waiting only for the right tools and a perpetually curious mind to bring them back to light. We would love to hear which of these transformed landscapes captured your imagination most. Was it the frozen moment of Pompeii, the cosmic